This is my Physics 2 Lab 2 about lines of charge. So the purpose of this lab is to determine the amount of excess charge on a piece of charged tape due to electron transfer and understand how charged objects interact, which is the same purpose as last lab. However, this time we are assuming that the charge is evenly distributed along the tape in a line in comparison to lab 1, where the charge is concentrated at a single point. Same important background information. The Q of an electron is 1.6 times 10 to the negative 19. The EVA field is calculated using KQ over R squared. The force of an electric field is Q times E external, which is Coulomb's law, and I'll use E field for this. And then force of gravity is mass times 9.8. And then the results are I calculated the strip has a charge of 4.117 times 10 to the negative 8. So this is just a recap on the experiment. So a charge tape is used to make a bridge, and then another charge tape is held underneath to make the bridge rise. So the system is the tape, the surroundings is everything else, and then I have the same initial conditions, but the only difference is I'm estimating the charge as one line, which means I'm using Q as 4.117 times 10 to the negative 8, and then you can see the rest of my initial conditions over here. And then here's my code. So I'm using just the regular physical constants and then the same initial values from lab one, which is the mass. And then I'm calculating this Q to balance out the force of E, or balance out the force of gravity with the force of E. So I basically just calculated that through that. And then this I copied from lab zero, like they said. I just changed the wording to match what they had over here. And then my scale is 0.000001, which I just calculated through trial and error to make sure that the arrow sizes matched up. And then in order to calculate the electric force on DQ, the top of DQ due to the bottom of DQ, you basically just take the charge from the top and multiply it to the DE of the top by the bottom because it's like the same. And then to create the arrow for the net electric field, I am just taking the E field at the top and then I'm scaling it with my scale factor. And then I pretty much do the same thing down here where I have to make these arrows, just taking the force value and multiplying it by my scale factor. And then here's the results of my code. You can see my picture over here of the charges and where they're going. And then this is the force of um, the electric force, and then this is the force of gravity. You can see they cancel out. Here's my values. So basically, I'm iteratively calculating the electric field and electric force from each infinitesimal charge dq to estimate the total charge. Then I'm calculating the force of gravity and determining the necessary Q on the tape to cancel out the force of gravity. And then, so for my conclusion and questions, what if I had modeled each of my tapes as a single point charge like in the previous lab, compare the values? So basically my charge from the previous lab is 2.567 times 10 to the negative 8. And then in this lab, I'm calculating 4.117 times 10 to the negative 8, which is around a 1.55 times 10 to the negative 8 difference. And why do these estimates differ? Which value is more likely to be closer to the real value? So these estimates are differing due to the fact that a line charge acts as a sum of multiple charges versus the point charge acts as just a single charge. Therefore, the second calculation, the one that I just found from lab 2, is more accurate because it more closely aligns with the shape and function of a charged object. However, there are still errors involved from the interaction of my hands with the charged object and also not treating the tape as a 3D object.